Hello everyone, my name is Shambhavi. Hope you all are doing well. So now I'll be discussing about the summary of all the formulas which we had seen into this relevant in this particular topic, that was the chi-square distribution, right? So here now we go with the summary of all the formulas. So here it's my topic summary of, and here goes the formulas, right? Yeah, this is what we are gonna study right today, and we're gonna take out a quick summary of the formulas so that at the time of revision and all these things, these particular quick summaries help us a lot while dealing with the questions and while dealing with all of the things, right? Okay, so I'll be starting up here with the quick summary. So what I'll be doing is that I would quickly take out a new color from this particular place. Let's say it's this one. Right here. So let's start out. So for the first thing, I'm just quickly going to discuss about the chi-square probability distribution. So the chi-square probability distribution, right? So for that, we are having the formula that's mu is equal to df, and we are having the formula that sigma is equal to under root of 2.df, right? These are the formulas that we are having out here for this particular probability distribution. Now let's move towards the topic, and that's the goodness of fit hypothesis test, right? Let me come down, get out some space for writing. Putting out a dot here, and yes, from here it starts out that it is goodness of fit hypothesis test. Okay, this is a topic, that's a goodness of fit hypothesis test, right? So the very first point goes here that use goodness of fit. Okay, instead of writing out the complete name, I would simply write or use this. Okay, use this test to find whether a data set fits a particular probability distribution. Probability, and here goes the distribution. Okay, right. So this is what this particular goodness of fit hypothesis is used for. It's basically used for checking out this particular to find that whether a data set fits a particular probability distribution or not. This is what it is used for, right? So yeah. Okay, I will just make out a little bit of change here. Just let me quickly open out remove out this notification thing. 1 second. Yeah, right, here it goes. Okay, so yeah, goodness of fit hypothesis test. So in this test, basically use the test to find whether a data set fits out a particular probability distribution or not. Right, this is what it is used for. Next, what we are having out here. So the second point, we are having the degrees of freedom. Let me come down here. That the degrees of freedom are number. So the degrees of freedom are number of cells or categories. Are number of cells or categories minus 1. Right? This is what the degrees of freedom are. So degrees of freedom are number of cells or categories minus 1. Fine. Next, we are having the third point. Now, what we are having here. So the test is statistic. The test is statistic is, what's the test statistic that we are having? So it's we have already seen sigma. Downside we were having k. Above we were having O minus E whole square divided by E, right? This is what we were having as a test of statistics. So test of statistics is this, putting out a comma and using out here that where O is equal to, we have the observed. O is equal to observed. Then we are having here values. Into the bracket, we will just put on the data. That's the data as well, right? So yeah. So this is about the where O is equal to observed values and the data. And what about E? What we were having as a E? So E was my expected values. So here goes expected, and here goes the values, right? And that's from the theory. So from, and here goes theory. Fine. So O is basically my observed values and E is basically my expected value, right? What about the K? We were having the K as well, right, into the formula. So K is the it's the number of different data cells or categories, right? So K is basically the number of different data cells or the categories which we have out. Okay, fine. Coming down here, next we are having the point number 4, and the point number 4 is that the test is right tailed. The test is the right tailed, right? So yeah, these are some rules. These are some, you could say, a summary, a quick recap regarding the goodness of fit hypothesis test, right? Hope I am very much clear with this particular. Next, I'll be moving forward with the test of independence, right? So here put the point, and here goes the test of independence. Okay, right here. So what I'm gonna first point which I have, that the use the test of independence. Use the test of independence. Use the test of independence to test whether two factors are independent or not. Are independent or not, right? So first of all, the test of independence is used to basically use the test for independence to test out that whether the two factors which are like they are independent or not. Right now, next point which we are having, the degrees of freedom. So here goes the degrees of freedom. So the degrees of freedom are equal to let me come down. So degrees of freedom are equal to, what are these equal to? These are equal to number of columns minus 1 into number of rows minus 1. So here goes number of columns minus 1, and next we are having number of rows minus 1, right? So yeah, this is the degrees of freedom, and that is equal to both of these particular things. Fine. Now moving next, we have the test statistic. The test statistic which we have for this is, so the test statistic is, we have here the sigma. Here goes I multiplied by j in the bracket, and next I'm having O minus E whole square divided by E. Okay, the test statistics is this. Okay, where now what are these all notations which I had put on? So I would just write on where O is equal to, it's the observed value. O is the observed value. Fine. What about E? So E is basically the expected value. It's the expected value. Okay, and what about the I and the J? So I is, okay, let me write it out. I is equal to the number of rows. Okay, number of rows in that table. So it's not, I do not think so to write out the that as the number of rows in the table. Okay, and what about the J? So J is basically the number of columns that we are having. So it's the number of columns. Right, so yeah, this is the formula regarding the test of independence for all of these particular things, right? Now what I'll be having next is that, let me just go down quickly a little bit here. Now what next thing regarding this particular, okay, it's the fourth point. So this particular test, the test which we are seeing, that is the test of independence. So the test is with the right tailed. It's right tailed. Okay. And next regarding the last point, that if the null hypothesis, is true, then basically then the expected number, number the expected number which we have, that is, if the null hypothesis is true, then the expected number, that was E, right? So that E is equal to row total, in the bracket we were having column total, row total, column total, and downside we have the total surveyed. So total and surveyed, right? This is what we have right out here. So if the null hypothesis is true, so in that case the expected number, that's the capital E, that was we have used in the formula as well. So capital E was denoting out the expected number, right? So it's row total into column total upon total surveyed, right? So hope I am very much clear with this particular thing as well regarding the test of independence, right? So here we had taken the summary regarding the test independence and the what was the above one that we had seen. So that was goodness of fit hypothesis test. Now we are left with two of the things, test of homogeneity, and the next which we are left out here with is the test of the single variance. So that will be seeing up in the next video. So this is all for this video. Till then, thank you and take care.